Good morning, everyone. I am Banay John Mark, and today I am going to solve AC circuit using nodal analysis.
So we are going to find the power in this impedance. First, we are going to find the KCL at node 1. This is V1 minus V2 over the impedance 3 plus 2J plus V1 plus V3. I mean V1 minus V3 minus V3 over 2 plus 3J equals the current going into the node 1. So this is I1. Next, we are going to find its value V1 over divided 1 divided by 3 plus 2J is equal to 0.277 angle of negative 33.69 V1. Next is this is the value. Next is negative 1 over 3 plus 2J is equal to negative 0.277 angle of negative 33.69 V2. Next, this one, positive 1 over the positive 1 divided by 2 plus 3J is equal to positive 0.277 angle of negative 56.31 V1. Next, the value of we are going to substitute the value for V3, which is 4 angle 45 volts. We are going to divide it to the impedance 2 plus 3J, which equals to negative 1.109 angle of negative 11.31. And the value for I1 is, I forgot to write, this is supposed to 2 angle 90 amperes. So the value of I1 is 2 angle 90. Next, at node 2 we are going to find the KCL. So this is V2 minus V1 divided by plus V2 minus V3 equals to I2, this one. So we're going to solve the values. So 1 over 3 plus 2J is equal to, 1 over 3 plus 2J plus 1 over 3 plus 3J is equal to 0.863 angle of negative 41.38 V2. For V1, it's just negative 1 over 3 plus 2J is equal to 0.277 angle of negative 33.69 V1. For V3, this is 4 angle 45. We're going to divide it. So this is going to be at the other side, since this is a constant, it has no variable at all. So if we're going to add this at the I2, which is 3 angle 90, it becomes 3.14 angle of 72.56. This is equation 4 already. This is equation 3, equation 1, 2, equation 3. Oh, this is supposed to be equation 2. So now we are going to simplify equation 2, and it becomes 0.544 angle of negative 33.69 V1 plus 0.863 angle of negative 41.38 V2 is equal to 2.47 angle of 63.92. This becomes equation 2 prime. From this equation 2 prime, we are going to find V1. 0.544. We're just going to rewrite it first. So in this part we are looking for V1. So this one we're going to transpose, this V2 we are going to transpose to the other side, and it should become V1 is equal to 2.47 angle of 63.92 minus this one 0.863 angle of negative 41.38 V2 divided by this one 0.544 angle of negative 33.69. we just simplify it. 4.54 angle of 108.42 plus 0.509 angle of 11.31 V2. So this becomes our equation 5. Now we will substitute this equation to equation 4. We'll just arrange it properly. So V1 comes first, 0.277, V1 plus 0.863, angle of 41.38, V2 equals 3.14, angle of 72.56. Now we are going to substitute this equation. 0.277, angle of negative 3, 4.54, angle of 108.42 plus 0.863 angle. Equals so we are going to use the next page. This time we are just going to group the we are just going to add the V2 to each other. Next we simplify this part and this part also. Now we can solve for V2. We just divide this part. I mean we divide both sides by this one. This should cancel out. We should get the value for our V2 as 5.95, angle of 118.2 voltage. Now to solve for our V1, we are just going to look at our recent equations. So here we can use equation 5. We just substitute the value of V2. And the value for V1 is 7.49, angle of 117.1 volts. So here we're almost already done. We're just going to use we are going to find the I. So this is the equation we are going to use. I is equal to V1 minus V2 over JO. Our JO is this one, 3 plus 2J. If we should get the value of our I as 0.418, angle of 79.065. amperes. Then I'm just going to write the equation is SVI, which apparent power is measured in volt ampere. Our volts here is 7.49 minus 5.95 angle of 118.2 multiplied by I 0.418 angle of 79.065. I forgot to write. We are going to multiply the magnitudes and add the angles. So this should become 7.49 multiplied by this should become 7.49 minus 5.95 multiplied by 0.418 angle, then the angle 117.1 minus 118.2 multiplied by this angle 79.065. So the power we calculated is 0.644 angle of 77.965 volts ampere.